1,000 times less power to run AI. 1,000 times.
We had to check twice.
We checked 3 times, and the number held.
What they're building could change every data center on the planet.
Okay, so June 25th, 2026, a company called Unconventional AI drops their first model into the world.
And nobody in the mainstream is really talking about this yet.
Right, so the name alone, Unconventional AI, like bold choice.
Very on the nose.
Extremely on the nose. But here's the thing. The founder is Naveen Rao, former head of AI at Databricks.
Databricks. So this isn't like some random garage startup.
No. This is someone who has been deep inside the machine, so to speak, knows exactly how it all works.
And then just left to go try something completely different?
Which, that's either visionary or terrifying. Maybe both.
Okay, but what did they actually release?
So the model is called Unzero.
Unzero.
Unzero, and it's an image generation model.
Okay, so like generate a picture of a cat, that kind of thing?
Exactly that kind of thing. But the how I O is where it gets weird.
Here's the thing. I read the blog post and I had to reread it.
Yeah, same.
Because it's not built like anything we've seen before.
It runs on coupled oscillators.
Coupled oscillators, which sounds like something from
Physics class. Yeah,
like high school physics, springs and pendulums.
right. And I mean, that's not far off, actually. An oscillator is just something that swings back and forth rhythmically.
So they're using rhythms to generate images?
Essentially, when you couple oscillators together, link them, they start to synchronize in really complex ways.
And those patterns of synchronization can encode information.
Exactly.
Okay, so conventional AI, transformers, diffusion models, all of that.
It's basically massive matrix multiplication, just numbers crunching.
On enormous chips, drawing enormous power.
Enormous. Data centers are now competing with small cities for electricity. That's not an exaggeration.
I know. It's actually, I don't know, there's no good word for it.
Unsustainable is the word they keep using.
So Rao looks at this and thinks, what if we just don't do it that way?
What if the physics itself does the computation?
Instead of forcing silicon to simulate math,
Right. Let the oscillators find their own equilibrium. That is the answer.
that's wild. That's genuinely wild.
And their goal, stated goal, is to cut AI energy use by
1,000 times.
1,000 times. Yeah,
That number doesn't feel real.
it doesn't. And I want to be honest here. There's a giant asterisk on all of this right now.
The simulation problem.
The simulation problem. So Unzero, the model they released, it's not running on an actual oscillator chip.
Wait, seriously?
It's running on a software simulation of what that chip would do.
So the efficiency gains aren't real yet?
Not yet. They're projected, based on how the architecture should behave, when it's eventually built in physical hardware.
Okay. So they're essentially saying, trust us, the chip will work.
Which is a lot to ask.
It's a lot to ask.
And here's where I actually started to come around.
The FIDE score.
The IV score, right? So FID, Fréchet inception distance. It's basically how you measure image quality in generative models.
Lower is better.
Lower is better. Unzero got a 6.74 on ImageNet 64x64.
6.74.
Which matches where the leading conventional methods were when they were first published.
So for a first model on a brand new architecture,
That's actually really good. Like, that's not a toy result.
that's a real result.
Naveen Rao called it the hello world of a new kind of computer.
Oh, I love that framing.
And they put their money where their mouth is, sort of the weights, the training code, the ablation code, all open source,
All of it? Public?
all public. You can go look right now,
So the research community can actually poke at this.
which is smart, because if it holds up under scrutiny,
Then it's not just a press release.
exactly. And they did publish a full research paper alongside it,
Okay, so the company is valued at, what was it?
$475 million.
$475 million for a company that has released one model.
One model that doesn't yet run on the hardware it was designed for.
And yet, I kind of get it.
I mean, so do I. If this works,
If this works, it's not incremental. It's not 10% better.
it's a different computing paradigm.
That's the bet. That's what 475 million is betting on.
And honestly, the timing makes sense, because right now, the energy problem in AI is becoming a real blocker.
Like, not theoretical anymore. Actual infrastructure limits.
So what do we watch for next?
The chip? That's the whole thing. Can they actually build it?
Because software simulation proving out the math is step one.
Step 2 is, does the physics cooperate when it's real silicon?
Or whatever substrate they end up using. That's still unclear,
And can they scale beyond image generation?
right? 64x64 images is a proof of concept, not a product.
But how do I even... Yeah, it's just wild to think about what's next.
It really is. Look, I came into this skeptical.
You always come in skeptical.
That's my job. But the open source release, the paper, defied results, this isn't nothing.
It's a real first step towards something potentially massive.
Or it's the most expensive physics experiment in startup history.
Could be both.
Could absolutely be both.
Okay, if this kind of deep dive is your thing,
Subscribe wherever you're listening. It genuinely helps us.
we'll be watching unconventional AI very closely.
Very closely, I'm Alex.
I'm Sarah. We'll see you next time.